This class is an introduction to polynomial expressions. So we're not really going to look at anything technical, no techniques in this class. I just want to give you an overview of what polynomials are. Polynomials form a huge branch of types of mathematical function. You're going to see a lot of polynomials. You've probably already seen them, you just never called them polynomials. So because they form such a big set of functions, which you'll probably use in future math classes, it's good to know what they are, like where they come from, how they're defined, and then just to pick up a few general ideas about polynomials. And then in later classes, you're going to start to work with polynomials and do things like factorizing them and sketching their graphs and solving polynomial equations. So polynomial, where does that come from? Well, the word polynomial, which is probably a good place to start, is made up from poly and nomial. So what do they mean? Well, poly, just like in everyday use, means like multiple or many. So we could just say that that means many. Nomial is a more mathematical term. So nomial refers to the powers. So power in the sense of like 3 to the power of 2. So in other words, the exponent. Okay, so you may call the powers the exponent. So power, exponent. So polynomial then means multiple powers, so many powers. So it's an expression which has got multiple powers, basically. But what does that exactly mean, multiple powers? Well, it means that the term, the variable term, like the x term usually, good old x, the x term is going to have multiple powers on it in a polynomial expression. So for example, you may have already seen quadratic expressions which have got an x squared term. So x squared plus something like maybe 3x minus 17. That would be an example of a quadratic type of polynomial. So that's a power of 2, that's a power of 1, that's a constant term, but you could also think of it as being an x to the power of 0, because anything to the power of 0 is 1. Normally we don't write that in, normally we don't write in the 1, but that's an example of an expression which has got different powers, so many powers, multiple powers, so it's a polynomial by definition. In general, polynomials start with some power and then descend, but you don't have to have every power in there. So for example, you could have, say, an x cubed polynomial, so a cubic polynomial they're called, but maybe it misses out the square term and then goes to like the x term, something like that. And then maybe has like a number term on the end. So you don't need to have a power of 3, a power of 2, a power of 1, a power of 0. You don't need to have every power for it to be a polynomial. So in general, polynomials start with whatever the highest power is, say x to the n, and they would have potentially some number in front, so we would maybe call that a sub n. So that's your first term. Then the next one starts to descend, so it would be a sub n minus 1, and that would be x to the power of n minus 1. And then it just kind of, the powers descend from there, and you take another one off, and blah, 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 and it's just going to carry on all the way down until you've got something like a, let me just put a plus there actually, until you've got something like an x term, and then a number term. In fact, let's put in the square term, so you would have maybe an a sub 2 x squared plus a sub 1 x, or x to the power of 1, I guess you could say, and then some number term which we'll call a sub 0 on the end. So that's just like your general form of a polynomial, but you don't really need to refer to that. When you're working with polynomials, this will be the furthest thing from your mind. You don't need to know that. But the point is that it starts with some power and then the powers descend until you get to your number term on the end, but you don't need to have every single descending power. You just need to have a selection, and that basically forms a polynomial. If you're taking a course in polynomials, it's likely that the ones you'll focus on are quadratics, cubics, and maybe the next one up, which is called a quartic, but I'd imagine probably these guys, because this type here, a quadratic, which has got a general form of ax squared plus bx plus c, they tend to not, they are a polynomial, but we tend to think of polynomials as being powers of 3 and above, because these guys are quadratics, and we learn about those generally long before we start thinking about this weird word, polynomials. We just learn them as quadratics, not as a type of polynomial. So we do need those, but we kind of almost discard them in a way. So the quadratics are kind of in a category of their own, I guess. So if you're taking a course in polynomials, you'll probably focus on cubics, So cubics are quite nice because they've got several algebra techniques like factorizing, which are fairly manageable. You can do them without them being horrible. And also the graphs of those types of functions are fairly drawable. You can draw them without turning into like a graphing utility. So they're usually the ones that we work mostly with. When you get up to powers of 4, like an x to the power of 4, everything becomes more complicated. So you might see those, but you probably won't focus on those quite so much. So in general, a cubic looks like ax cubed plus bx squared plus cx plus d. So again, just getting all your descending powers. The thing that makes this a quadratic, by the way, is the x squared term. The thing that makes this a cubic is the x cubed term. So these are specific names for certain types of polynomial. So if the highest power is a squared, it's a quadratic. If it's a cubed, then it's a cubic. And like I said, you might see some examples of an x to the power of 4, and that's called a quartic. Let me just give you an actual example of a quartic. So you could have something like x to the 4 plus 2x squared plus x minus 12. So that would be an example of a quartic polynomial. Okay, and that one's a quartic because the highest power is the x to the 4. Whatever the highest power is, by the way, we call that the order of the polynomial. So that's a good term to know. So when you're talking about a quadratic, you're talking about a power of 2, so an order of 2. For a cubic, it's an order of 3. For a quartic, it's an order or a highest power of 4. The order becomes important once you start working techniques with polynomials because certain features of polynomials are related to their order. So for example, when you start working polynomial equations, you will only get a maximum number of solutions equal to the order of the polynomial. So for example, you may have already seen quadratic equations when you can only have 2 solutions maximum. Cubic equations, where this would be equal to 0, you can only get 3. Quartics, you can only get a maximum of 4, that sort of thing. So pulling that all together makes polynomials quite a neatly packaged topic, really. If you stay within these kind of areas, once you get up to higher powers, it gets more and more cumbersome and more difficult to work with. So that's really just an overview of what polynomials are, just expressions that have got multiple nomials, multiple powers, and you'll recognize them mostly as quadratics, cubics, quartics, and in general, something that looks like that guy up there. So nothing really to practice from this course, no technique, just a case of trying to get some of the terminology down. And just now, basically, you know what a polynomial is, and maybe you didn't know what that was before.